Everybody wants to build SaaS with AI, but very few are shipping something that actually works. And I'll tell you exactly why. They're skipping the boring part. They go straight from idea to prompting and wonder why they get garbage back. Today, I'm going to show you the exact workflow I use to build production software with AI. It's less sexy, but it works and it's fast. I'm Sean. I've bootstrapped SaaS products for 15 years, and I'm currently building Clockless, a legal billing SaaS, entirely with AI tools. So I've lived through what works and what doesn't. Here's what most people do. They open Cursor or Claude code, they type something like, build me a dashboard. They get some code back, they look at it and they say, close enough, and they move on. That's vibe coding. And for a quick prototype or a throwaway demo, it's fine. But if you're building a real product, something customers will pay for and depend on, vibe coding will bury you in tech debt within the week. You'll spend more time fixing broken things than building new things. I've seen founders lose entire weekends debugging code that should have never shipped. What I'm going to show you instead is context engineering. It's a structured approach that turns AI from a loose cannon into a precision tool. And once you adopt it, you'll never go back. Here's the full workflow in 5 steps, and I'm going to walk you through each one. Step 1 is to outline your requirements. Step 2, we want to break those requirements into modules, which are basically the big features of your app, like auth or your primary workflow. Step 3, we need to break those modules into tasks. Step 4, we need to ask AI to complete one task at a time and test it after each step. Step 5 is to feed what you learn back into your project guidelines. Now, the key insight is this. You never ask AI to build something vague. You ask it to build something specific with clear acceptance criteria, and you verify it works before moving forward. That's the whole game. It's an iterative approach to real progress. Now, before you create a single prompt, I want you to write down what you're building. Let me show you an example. You're not writing a dashboard. It's something more like a client management screen that displays a list of clients with name, email, and billing rate. Users can add, edit, and delete clients. Data persists to the database via API. The list supports search and filtering, right? A lot more context. Do you see the difference? The first version, just build me a dashboard, leaves the AI guessing about every single decision. Your second version tells your agent exactly what success looked like. For Clockless, the app I'm building in public, every feature starts as a short requirements document. I include what it does, who it's for, what the inputs and outputs are, what the edge cases look like. This takes me about 10 minutes, but in the end, it saves me hours. Now, once you have your requirements, you need to group them into modules. And remember, a module is basically just a logical chunk of your application that can be built and tested independently. Let me show you what I mean. So for that client management feature, my modules might be Module A, database schema and API endpoints. Module B, client list UI with search and filter. Module C, add and edit client forms with validation. Why modules? Because each module gets its own test suite. When you finish Module A, you run end-to-end tests on the API. If they pass, you know your foundation is solid before building the UI on top of that. If they fail, you know exactly where the problem is. Think of modules like floors to a building. You don't build a third floor until the second floor can hold weight. The next step is to break each module into individual tasks. A task should be small enough so that AI can complete it in one prompt and you can verify it in under 5 minutes. So for Module A, which is the database and the API, my tasks might be, for example, Task 1, create the client's table schema in the database. Task 2, build the get endpoint to list all the clients. Task 3, build the post endpoint to create a client. Task 4, build the put endpoint to update a client. Task 5, build the delete endpoint to delete a client. You get the idea, right? Now you can also just spell this out in a basic way. Something like, I need a place to store client information in the database. We need to display our list of clients here. We also need the ability to update or delete a client record, and AI will translate all of that for you. Now, each task has clear inputs, clear outputs, and a test that proves it works. This is where most people go wrong. They try to get AI to build the entire module in one shot, and that's just too much ambiguity. The AI makes assumptions you don't catch, and they compound into bugs. Remember, keep the tasks small, clear criteria, and one at a time. Now here's where the magic happens. You give AI one task at a time, it writes the code, and then you are the person who's going to test it. Getting the testing cadence right is critical. After each task, run a unit test. After each module is complete, run end-to-end tests. Now, unit tests verify the individual piece works, but end-to-end tests verify the pieces work together. This is a two-layered approach that catch bugs at the smallest possible scope so we can fix them before they become bigger problems. This is the rule I generally live by. If the test passed, keep moving and don't review the code. If the tests fail, then review the code to find out what went wrong. If it was an isolated issue, just fix it. If it has become a pattern, update your Claude MD file or your rules file so the agent doesn't make that mistake again. I know this part sounds counterintuitive. Engineers are trained to review every line, but think about it. If you have a solid test suite and everything passes, what exactly are you reviewing for? Style? Preferences? Realistically, you're probably just wasting time. The tests are your quality gate, so trust them. Keep in mind that it's important for us to balance being thorough with speed. In the AI era, you will lose a lot of the value if you can't figure out how to balance these well. Now let's take a look at what happens when tests fail. So you look at the code with AI's help to figure out what went wrong. And 9 times out of 10, the failure reveals a potential gap in your requirements, not a gap in the AI's ability. Maybe you didn't specify an edge case. Maybe your acceptance criteria was ambiguous. Maybe you assumed AI would handle authentication in a certain way and it didn't. And this is where step 5 comes in. And it's a step that separates amateurs from professionals. Every time you discover a misdesign pattern, an edge case that AI didn't handle, or a convention it didn't follow, you don't just fix those and move on, because that means they're likely to come back. You document them in your Claude MD or your rules file. If you're not familiar with Claude MD, it's a project-level instructions file that Claude Code reads at the start of every session. It's your AI's persistent memory. It's the context in context engineering. For example, when I was building Clockless, I discovered that AI kept generating API endpoints without proper error handling. So I added a guideline to my Claude MD file, which stated something like, all API endpoints must include a try-catch block with specific error codes and user-friendly error message. Never return the raw error object to the client. From that point on, every endpoint the AI generated included proper error handling. I never had to fix that issue again. This is the compound effect. Your Claude MD file will get richer with every task you complete, which means your AI will get better with every session. Only a week into building Clockless, my Claude MD file has dozens of guidelines covering everything from database naming conventions to how authentication should work to how API responses should be structured. The AI barely makes mistakes on those patterns anymore because I've taught it through documentation, not through hope. This is a fundamental difference between context engineering and vibe coding. With vibe coding, you make the same mistakes over and over again because the AI has no memory. But with context engineering, your agent gets smarter over time. Allow me to recap the full workflow. Requirements are all about being specific about what you're building. The modules are where you're going to group work into testable chunks. Tasks become those atomic units that the AI can complete one at a time. Building and testing is all about leveraging unit tests after each task is complete and end-to-end tests after each module is complete. If the tests pass, keep moving. If they fail, investigate. And if you find something, update your Claude MD or your rules file every time there's a lesson so that you can turn that into a permanent guide. Now, here's the homework for this week. Take whatever you're building or whatever you want to build and write your requirements for one feature. Break that into modules and tasks. Then feed those tasks into your AI tool one at a time so that you can test each one. I guarantee you will ship faster and with fewer bugs than anything you've built by leveraging something like vibe coding or just hope. If you want access to my full framework for launching a successful bootstrapped SaaS business, check out my free 5-day email course in the description below. I've also turned everything that I've included in this video into a guide for you, and that is also free. Check out the description below for that as well. I'm Sean, this is Bootstrapper's Paradise. Remember, it's context engineering, not vibe coding, and I'll see you in the next one.